So we've learned how to measure the amount of solute in a solution, and we've called this the concentration of a solution. Okay? We can measure concentration in 4 different ways. The first way we learned was in grams per liter. We can also measure concentration in 3 other ways. The one we're going to focus on here is called molarity. And what molarity is the moles of solute divided by the volume of solution. So what we need to figure out the molarity of a solution is how many moles of solute are in the solution and what is the total volume. Okay? So for example, let's say we take this solute, we drop it in, and we have 2 moles of solute. And the beaker has 4 liters of solution in it. So if we calculate the molarity, which is abbreviated with a capital M, we would say that there are 2 moles in 4 liters. So 2 divided by 4 would be 1/2. You could write this as moles per liter, which is the same thing as 1/2 molar, capital M. So here are 2 example problems you would have to do using your knowledge of molarity. Number 1, a solution of CaCl2 is created by mixing 4 moles of CaCl2 in 8 liters of water. What is the molarity of the solution? Since you have 4 moles of CaCl2 in 8 liters, this is your keyword. What is the molarity? So what I would rewrite right away is this means moles over liters. So how many moles do we have? We have 4 moles divided by the number of liters, which is 8 liters. So if we do the math here, 4 divided by 8 gives you 1/2 molar. Number 2 says, how many grams of NaOH are needed to make 4 liters of a 4 molar solution? Okay? So here this is slightly different. We're given 4 liters and we're given 2 molar. It's asking for how many grams. Well, remember, 2 molar is the same thing as 2 moles over, just like grams per liter was the number of grams over 1 liter, 2 molar means 2 moles over 1 liter. So the same idea that we did with grams per liter applies here. We need to take our volume and multiply it by the concentration. Volume times concentration. So in that case, what we have here is our volume 4 liters times our concentration 2 moles over 1 liter, which gives us 8 moles. Now, a lot of students will stop here. The problem is, the unknown in this problem is how many grams. So what we have to do is we have to remember our stoichiometry. We have to convert from the number of moles that we have to the number of grams. So you got to remember how to do this. To convert from moles to gram, we need to use the molar mass, which is in 1 mole of NaOH. You have to add up the molar mass of NaOH. Na is 23, O16. Hydrogen 1, based on the atomic masses on the periodic table. If you add 23 plus 16 plus 1, you get 40 grams. So 40 times 8 would give you a final answer of 320 grams. Here are 2 more problems. I want you to go ahead and give these a shot by yourself for practice. When you are done, press play, and I'll go over the answers so you can see if you did them correctly. Press pause now. So for number 3, you're given 6 moles in 2 liters. We're asking for molarity, which means moles over liters. So the correct answer here would be 6 moles over 2 liters. 2 liters, which equals 3 molar. Number 4 asks how many grams of CO2 are present in 2 liters of a 2 molar solution. So I'm going to do volume times concentration, rewriting molarity as moles over 1 liter. These cancel. This gives me 4 moles. Well, then I got to convert to grams, so I have to multiply this by the molar mass of CO2. which is 44 grams. So the final answer here would be 4 times 44, which gives you a final answer of 176 grams. If you feel confident with molarity, go ahead and log on to your iPod or Chromebook, log into Exit Ticket, and answer the questions on Learning Target 5.5 on molarity.